Hey YouTube, welcome back to my TypeScript series. In this video, we'll be going over what TypeScript actually is and why it's beneficial. So the reason why TypeScript is beneficial is because it adds types to JavaScript, and what types gives us is more safety and a stronger guarantee before our program gets executed at runtime. So let me give you an example. I think it'll explain it the best. Let's create a new file called add.js. And in this file, let's create a function called add, which takes in two parameters, a and b, and it returns the sum. And let's log the value produced by add when we pass in 9 and 10. So if we run this in Node, we get the value 19, which is what we expect. But what happens if I, by accident, enter a typo and I pass the string 10 instead of the number 10? If we run the code again, we actually get the value 910, which is unintended behavior. This is a bug that we do not like. JavaScript tries to be smart and converts 9 to a string and then concatenates it with 10, and then it produces the string 910. And the reason why it does this is because JavaScript is weakly typed, and that's the reason why a lot of people don't enjoy working with programming languages that are weakly typed, is because it's hard to prevent bugs like this. So let's convert this JavaScript to TypeScript and show how adding types can actually prevent type errors like this. So to write TypeScript, you need two things. You need the compiler, and you need an editor that supports static type checking. So to install the compiler, you can either install TypeScript with yarn or npm. I'm going to install it with yarn, and you want to install it globally so it's available everywhere in your system. And I will add to next to get the latest TypeScript. So as you can see, it actually installs two binaries. It installs TSC, which is short for TypeScript compiler, which will actually compile your TypeScript code to JavaScript, and it also installs TS server, which is the language server to support the static type checking for your editors. If you don't know what that means, it's okay. You'll find out in the next few minutes. So to actually convert this JavaScript to TypeScript, what we need to do is simply just change the extension of the file to .ts. So this is valid TypeScript, and what this means is that all JavaScript is actually valid TypeScript code. And this is because TypeScript is actually a superset of JavaScript. And what this allows is people and companies that have massive JavaScript code bases to incrementally adopt TypeScript. There's no real breaking changes. So to actually prevent this bug, let's tell TypeScript that for the add function, we expect a to be a number and b to be a number. And then in here, when we actually call add, if we try to pass in a string here, TypeScript actually gives us a type error saying that the argument of type 10 is not assignable to parameter of type number. And this is why adding types is so beneficial, because it catches bugs like this before our JavaScript gets run at runtime. So then we can fix it at 10, and then we can compile our TypeScript with TSC, and then the equivalent JavaScript code will be produced by the compiler in the same directory, and then we can run the JavaScript with Node. And as you can see, we get the correct thing called 19. Now, one thing I wanted to show you is an editor that supports static type checking. So VS Code is a great editor because it's created by Microsoft, and Microsoft is the team that runs TypeScript as well. And as you can see, if I hover over A, you can see that VS Code tells me that this is a number, and I can do number-like things. And yeah. So now you know that TypeScript is a superset of JavaScript, and all valid JavaScript programs are valid TypeScript programs. But the converse is not necessarily true. all TypeScript programs aren't necessarily JavaScript programs. So as you can see, this is the .ts, and if we try to run this with Node complains because it says, hey, we have a syntax error. I have an unexpected token, and this is the colon. And this is because there is no colon, there is no such thing as a colon or type annotation, which we'll get into later in another video. There is no such thing as this in regular JavaScript. So the last thing I wanted to mention is TypeScript does not affect the way your JavaScript code runs. And this is because after you run the compiler to convert TypeScript to JavaScript, at the end of the day, what you're running at runtime is JavaScript code. So if we actually change this 10 back to a string, JavaScript will complain, and hopefully as a developer you'll fix this bug and convert it back to the number 10. But let's say you don't fix this and you try to compile it. TypeScript will still say, hey, it looks like you are violating the agreement, the contract of add, but it'll still actually produce the JavaScript code. So then if we actually run the JavaScript code, the bug still occurs. And yeah, this just goes to show that TypeScript types are independent of the code at runtime. So when the TypeScript compiler compiles this TypeScript code, the types actually go away, and what you're left off with is vanilla JS. So yeah, that's just one thing to note. At the end of the day, your code that gets actually run at runtime is JavaScript. So if someone is actually using your code outside of your code base and it's not using TypeScript, let's say this is your code base and then this is someone else's code, they can still actually misuse your function and still produce type errors like this. So just one thing to note.